little under 30 seconds. Should have a nice view of the Proton as it lifts off today. T-minus 15, and we'll listen to the Russian broadcast.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
We have ignition. And we have liftoff of an ILS Proton from the Baikonur Cosmodrome in Kazakhstan with the Inmarsat-5 F2 satellite on board. About 10 seconds after liftoff, the vehicle does do a roll maneuver, which aligns the launch vehicle pitch axis with the northeasterly launch azimuth. Now, the vehicle will soon experience maximum dynamic pressure, or max Q, which is the maximum aerodynamic stresses on the vehicle in atmospheric flight. And for Proton, max Q occurs around 1 minute and 2 seconds after liftoff and at a velocity of about Mach 1.6, and is sometimes accompanied by visible condensation if the atmospheric and lighting conditions are favorable. And here you can see it occurring now. We're just a little over 1 minute from launch, and we just went through max Q. Beautiful view there as the vehicle heads downrange, or we like to say in the rocket world, climbing up the hill. And everything seems to be proceeding nominally as the vehicle ascends over the Cosmodrome in a northeasterly direction and with a flight launch azimuth of approximately 61.3 degrees. About 90 seconds after launch, everything proceeding nominally. We'll have second stage ignition here in about 30 seconds. Now we're coming up on the first stage separation from the second stage, and that's set to occur at 2 minutes into the flight. And on clear days, observers will see a bit of a halo effect of light as the second stage engines ignite prior to the separation from the first stage. And we have confirmation of ignition of the second stage and a good separation from the first stage. And we have confirmation of planned level of thrust on all 4 stage 2 engines. And the second stage will operate for about 3 minutes and 27 seconds. The next key mission milestone would be the separation of the third stage from the second stage at L plus 5 minutes and 27 seconds. About 20 seconds after that event, the payload fairing pyros will fire, and that will separate the 2 halves of the payload fairing and jettison them from the vehicle.
In Step 1, with a planned initial launch capability in 2019, Vulcan will consist of a single high-performing, high-capacity stretch booster stage, along with a new American engine and up to 6 new high-performing solid rocket boosters, providing 20% greater thrust. By 2023, with the addition of the Advanced Cryogenic Evolved Stage, or ACES, Vulcan will achieve 30% more capability than the Delta IV Heavy. ACES can execute complex on-orbit operations, almost unlimited burns, and extend on-orbit operating time from just hours to weeks, and if required, on-orbit indefinite operations. ACES is the most efficient high-energy upper stage ever designed, making it the sports car to the stars. Sensible, modular, autonomous return technology, or smart reuse, will also be introduced into Vulcan, allowing reuse of the most expensive portion of the first stage, the main engines, via mid-air recovery. The engines are 25% of the booster weight, 65% of the booster cost, and inherently reusable. ULA's approach provides a benign entry, descent, and recovery process utilizing hypersonic re-entry with advanced inflatable shield, guided parafoil descent, and helicopter mid-air capture. Another innovation is distributed launch, which combines the performance of 2 launches through on-orbit refueling to enable heavy payload missions with high energy requirements. Vulcan will open up enormous possibilities, and the sky is the destination. Commercial asteroid mining, commercial habitats, multiple planets populated. The results? 350% more lift, 10 times greater duration, more than 100 times more on-orbit operations, and starting less than $100 million per launch.